Hey, Logan. All right, we're going to do continuity and one-sided limits. We're going to start them today. Watermelon, Jolly Rancher. All right. There's 3 types of continuity.
Wait, I need you to stop.
I have wrote literally 3 words. Alright.
No, I said stop.
Why? Yes, she did.
Why?
It was on the front.
Oh.
It was on the front of my desk when they come up. You ready? Yeah, okay. First is continuous.
Why is everything so funny in this class? Like, this is weird.
I have no idea. Alright, what does continuous continuity means? Anybody? Y'all laughing like y'all know what it means, so what's it mean?
It's continuing.
The graph don't break. Okay? The graph don't break. Alright, next one. Is jump discontinuity. Yes, you did this in pre-cal. This was right at the end of pre-cal. Okay?
I wish not so long for my name about it.
What do you think jump discontinuity means? The graph jumps. It breaks and jumps from one point to another. Huh? No, most of these are going to be piecewise functions. So I would say the graph jumps from one section to another. And most of this is piecewise functions. We ain't gonna talk about how bad that was spelled, okay?
Yeah.
And then the last one is called removable discontinuity. This is with the hole. This is to break your ankles. Okay, this is when part of the graph is removed. And it's normally a point. Removable discontinuity is also sometimes called point discontinuity. Okay? This is the same as point discontinuity. Right, Anna?
Why are you calling out Anna?
Because she's talking about a movie, it sounded like.
It was a good movie.
What movie is it? That has a good movie.
Okay?
What?
And y'all got a part when it was in like a chemistry lab or whatever. Yeah. Where her and the older brother, I forgot his name. No, there's no other investment.
All right, you got it? Everybody got it? Jones, you got it? I'm having a brain fart on her name. Sally, you got it? Okay. Camden, you got it, babe? Okay. All right. For continuous continuity, there are certain rules. So these are going to be our continuous continuity rules. Yeah. Okay. For a continuous continuity, it means, whoops. For a function f of x, the following is true.
It's for a continuous continuity stuff.
Yeah.
All right. 1. F of c is defined. The following is true. Let me add in here, for the function f of x, the following is true. Trying to think of a way to paraphrase this.
C is any number, right?
Yeah, f of c is defined where it's continuous at c. Say where continuous at c.
What?
C is any number that the graph is continuous through, basically. So I'm going to use C. So C is any number the graph's continuous through.
Any number on the graph.
Any number on the function, any y area, yeah. F of C is the y number. C is like any x. It's continuous.
I don't get why you put word continuous.
Because I'm using C here, but I didn't say nothing about C in the definition. So like if you just read that and you didn't know the word continue, that we're talking about a point C, then it could throw you off. And you know, I'm recording this for Logan, so I'm trying to include a much in there. Love you, Logan.
That's not weird.
All right, number 2. What, that I love Logan?
Do you actually love your students?
I don't like love them, but I mean, I care about them and I don't want nothing to happen to you. And then some of them, I mean, I've had them for so long. I mean, I've bonded with
I
them.
think you care for them.
I would be sad if something happened to you.
I don't know about that, my friend.
Remember last year when Pam was like we turned the project, and she was like, "These are my butt."
Oh, yeah. You better have your project.
Okay,
Which one I want?
that's kind of the speech I gave my first, or second, third today about the projects. All right, the limit x approaches c of f of x exists. Okay? And it's kind of the same thing with y'all. I need that by Sunday night.
Oh, yeah.
I remember that.
All right, yeah, this is a good question. All right, what this means, hey, limit. This means it's continuous on both sides of it, right, at C. Now, for a function to be continuous at C, does it mean the entire function is continuous? Why not, LJ? Okay, I'm going to show you graphically. He is right, but I'm going to show you graphically. The last step, our characteristic of this, is the limit as x approaches c of f of x equals f of c, like if I plugged c in. Okay?
Duh. Okay.
It's a long way since the whole.
Yeah. But it doesn't mean the entire function don't have holes. Just at the section of c. Okay? So to answer or to elaborate on the graphing for LJ, what I said to him, if I drew this beautiful picture, something like that. Okay? Gorgeous picture. Is that a continuous function?
Oh my God.
As a whole. This is f of x. F of x as an entire function is not continuous. But I call this C. Would f of c be continuous? Yes. There's no holes, and f of c would only pertain to the part of the function that's with c. Would the limit of f of c be the same as the evaluation of f of c? Would the limit
Yeah.
be the same?
Yeah.
It would, because let's say like this point here, let me change colors, is H. Okay, so what is the order pair for that dot?
See.
C what? CH. Okay, so that means when X is C, f of X is H, right?
Yeah.
Okay, so if I did the limit and we approach C from the left and the right, do we still go to H? Yeah, so they would be the same. So even though the entire function is not continuous, the function at f of C is continuous. Like if C was here, yeah, that one wouldn't be. Okay?
I see that, but I don't see it now.
All right, y'all good? Y'all understand that?
Oh, yeah.
All right, what about this?
Oh, that's not all.
All right. Shh. We got this function, okay? Hey, let's do another part of the function. Let's say, well, we can do where LJ was just talking about. All right, shh. Focus. At D, is D f of D continuous?
No.
LJ said no.
It's removable discontinuity.
That one is actually a jump discontinuity because I jumped from one section to another section. Okay? But if they were connected and there was just a hole, that's a removable. This is a jump. The reason why f of D is not continuous is because it doesn't meet our three things. Number one, we can clearly see the graph broke. What is the limit as x approaches D of f of x? What would y'all say that limit is?
D not whole line.
This right here, this dot goes with D, okay? Is that better?
Oh, okay.
So what would the limit be? As x approaches D from the left and right. Is there one? There's not one because up here it's going to be, say, G, but down here might be I, right? They're not the same letter. Okay? What is the evaluation of f of D? What does that equal? That's an I, right, y'all? Yeah. What's the evaluation of f of D? It's I. And the reason why it's I is because I is the closed circle where G is the open circle. So that's the difference. So y'all kind of see that? Does that make sense? It kind of goes with some of our graph and stuff that we were just looking at too, on how they do those graphs. Okay?
No.
It probably was.
Not right now.
And the assignment I just assigned you deals with some more continuity. So y'all do a little bit more of this and then some plugging in and stuff. Alrighty.
No.
Is that everything I want to do?
I don't know.
I got
drawing.
dog
I'll figure it out.
Alright. Okay, go on.
Yeah.
Alright, I want to look at an example. I want to discuss the continuity. So this example one, we're going to discuss the continuity.
Why didn't you do the rules for jump discontinuity?
Continuity. Jump discontinuity just means the graph jumps.
So like we're not gonna have any rules for either of those two. Okay.
Sally, what you rolling your eyes for? Shaking your head.
As mean as he is to me, I'm still.
How is he mean to you? He don't even talk to you.
Exactly. Yeah.
Your brother make a homework here today?
Hey, we went to a game and he drove. Let me tell you.
Let's discuss the
I
continuity.
really gotta get this off my chest now. And right there in front of UCP, like there's like gravel because they're fixing the road. Seth runs just straight over it. Doesn't slow down. There's like huge bumps. I think you would miss it. He was driving.
What's he got?
He was driving my car. They don't have a car.
So the C on your graph was continuous, right?
What'd you say?
The C on your graph was continuous.
Yes.
The D on your graph was jump.
Yeah, so it's not continuous.
Did you do removable?
No.
Okay.
We're fixing to look at some continuities. Write this one down, and then we're going to draw the graph or get the graph. I'm going to cheat.
I'm loving playing with this because I can cheat like you can.
All right.
I'm gonna get you spelled.
I wish I had this. I don't like the car I have.
So am I ready?
No, I'm fresh.
Focus.
I do a long driving.
F of x equals 1 divided by x. I'll leave Connor alone. Oh.
I still drove the tank, it blew up. It was my car. Yeah, that was like an 07 Ford Focus.
That's not really old.
Y'all should have heard it, the thing blew up! It stopped working in the middle of the road and somebody started honking at me. Well, I bet you it works better than the tank did.
Alright, this is the graph of f of x of 1 over x. You need to roughly draw the graph.
I don't think it's
Let me tell you this, there will be no JV football practice today. No JV football practice today.
Yeah, I've hacked your phone and stuff.
Oh, that's one.
My brother has my keys on there. Let's get the keys. Because he left his stupid gym bag in the truck. So.
Alright, y'all ready?
Whoa. So that's
What kind of,
0, 2, 4?
yeah, it's a rough sketch.
I can't see
You
it.
don't need that.
You don't really need the numbers, you just need the shape.
Just a shape.
What? Shh. Is this a continuous function? Anna, is this continuous?
Yes. Wait, where? Where?
Through the whole function.
No.
The whole function is not continuous.
Wow. What?
Why? What kind of discontinuity is this? This is a jump discontinuity. Because we jump from one part to the other part. All right, now if I said at when x equals 2.
Okay, you told me I didn't need the numbers.
When x, you can just look on this one.
Yes.
When x equals 2, is it continuous then? Yes, it is.
So that's
Okay.
because it's the one that's going all the way down.
Well, x equals 2, the reason why it's continuous there is because if I do my little, use highlighter, if I do my little thing at 2, I hit the graph at 1 point. Mm-hmm. Yeah,
Yeah, you feel like
the roses.
Do you know those?
I don't know, I have to look at them. I don't know right off the top of my head. B, we did them last year, but I have to look at them because, all right. Same thing, discuss the continuity of g of x equals x squared minus 1 over x minus 1. I'll do it on Desmos real quick. Just because cheating on these are easier. And I gotta put parentheses in.
No, equals.
Oh, I forgot my equals. It was there. I must have went too far back.
Yeah.
All right.
You could have just copied and pasted it.
Wait, go back. No,
What do y'all notice about this?
It's a continuous direct line,
It's a straight line.
but it doesn't go.
What was the...
Is it completely continuous?
Yes.
Yeah, okay.
Oh my Jesus.
He said, look, I need to see what B is.
Y'all be...
Okay, wait.
Y'all...
Hold on. Is it completely continuous?
Yes.
All right, let's see. Hold on.
You're going too fast.
Put it in the basket. Okay, x equals 1.
You're confusing Tiny Bird.
take time to pay attention.
Okay? Y'all see x equals 1 right here, right? Here is x equals 1 on the green graph. I can get a touch. Okay? On the blue graph, it shouldn't be there. It should be a hole. The reason why is this is a difference of perfect squares. And what happens to the ones on the x minus 1? Cancels. So it's actually a removable discontinuity.
I don't know what you're saying.
Because there is a hole at what number? 1. Okay? If you look at the graph, though, it looks very much continuous. And unfortunately, that is something that happens if you're not paying attention. Let's see, x equals 1. It's a removable discontinuity. Trying to get it in there. And this isn't going to show it, but it is a removable discontinuity. It's a removable discontinuity at x equals 1.
Okay, so
Everywhere else on the graph is what?
excuse you.
It's okay, it's continuous. And if I found the limit of this function, the limit would be whatever number is in the function there. Okay, but because these two could cancel, the function technically would have a removable discontinuity. Okay?
No, it's not okay.
What time's the bell ring? 3, right?
Yeah.
It took me.
Okay, you're just going too fast.
You're looking at a side, so it's taking you longer to write it.
No, I'm just trying to, I was perfecting my graph.
Don't South Road get out at 2:45?
I don't know. I don't go to South Robin. I don't teach there. Just saying.
Wait, so it's only removable discontinuity at
It's only x equals 1.
How will we know that?
You would have to factor it. Like if you've got 1 and you got a factor and the top and the bottom, the factors would cancel. Remember we talked about, and this was part of our review, was that anywhere you have 2 factors, a top and a bottom that cancels, that creates a hole in your graph. Okay, that's when we did the asymptote review. Because whatever cancels out, set it equal to 0 and solve it. And in this case, it's x minus 1, so it would be at 1.
Right. Okay.
Okay? Next one. Ready? What example is this?
3, well, 2, technically, because you did A and B.
Oh, I did A and B, so this is going to be C. This is going to be the same stuff.
Are we going to have another graph?
Of course.
I got to copy and paste my graph. Thank you. Oh my god. Sorry.
Isn't that song one talking on their whole page? I heard that.
All right, y'all got this written?
Well, they're only good.
You got it, Camden? Less than or equal to 0.
Oh, there's only 2 symbols. X plus
You ready?
and less than or equal to 0.
You said it was on the closet on the other side.
Yes, ma'am.
This is just making me.
I gotta remember how to do this here.
Party remarks?
Yeah, like, where's, like, saying.
That's not right. I forget how to put these in here. I'm gonna do it without putting the inequality, and we'll just look at it with the inequality aspect, okay? Because I forget how to do it, and I don't want to spend the time here to refresh myself. Oh, I'm sure she can. All right, look at this graph.
do like 1.
Okay. Let's grab this one and throw it up there. I ain't gonna record in this class no more because my good kids, my AP students act the worst.
So that's going through 1, and that's going to.
All right, let's look at this graph. What about this one? Is this a continuous function or not? Because technically you're looking at within the bounds of the inequality. The linear is only for x is less than 0, and the parabola is only for x is greater than 0. So what that means is basically this part of the line is gone, this part of the parabola is gone.
Is the first one x squared or x?
So all that's left is the blue line, this, and this. Is it a continuous function?
Yes, it's the black.
Yes, it is. No, the black's not. That's the inequality. I just didn't feel like messing with Desmos to put it in.
The other part of the graph is up here.
That comes up on it.
They don't cross the 1 and 2. They cross at 1 and 0. They cross at the order pair 0, 1.
I get that.
Okay.
So,
The parabola only counts on the positive quadrant 1 side. The linear only counts on the negative side. Because it was an inequality, it was a piecewise, it had bounds in it. I just didn't graph them in it, okay? Because you can, but it's aggravating. You got to go through so many steps, and I didn't feel like messing with it. Okay, and you can do them on your regular calculator though, and see them. This one actually would be continuous. Even though we got two totally different functions, it doesn't stop because of that inequality sign. Okay? So this one would be 100% continuous function. Yay! One more. One more. Y'all got 5 minutes. What y'all in a hurry for?
You didn't know Ben, she was I know what you mean. Sarah?
yeah, I literally forgot. So she like kind of hinted at me that she wanted me to make it on.
All right. Y equals sine x. Y equals. I did say whiny. I didn't mean to. Y equals sine x.
Boy, I'd be right. So she.
Somebody please make me your hand right. So you can just see. She said it 4 times.
Yep.
Oh, I was about to say something, but it's for your like function, so I'm not say that.
All right. Look at this one.
Are we doing example 2 at this point?
No, we're on D.
What?
What?
I just put them all on the same row. Like, I moved them and resized them and everything, so it'd be pretty.
Well, we're on D. All right. Sine x. This is also continuous function. Does anybody know which trig functions are not continuous for the whole function? And?
But after I
And? That's it. Tan, secant, cosecant, and cotan.
And Ashley doesn't know.
Sine and cosine are the only 2 of the big 6 that are continuous. Okay? Any questions? What we are going to do Monday is one-side limits and closed intervals, and we're going to start looking more particular in this. Today was more so getting the vocabulary.
Did you say 15?
Cotan. All right, any questions?
I don't know what's going on.
We were just looking at the graphs.
Oh.
All right, let me stop